In this video, we'll look at the sampling distribution of the sample proportion for a binomial experiment. So for this example, we have a population proportion of 0.6, and then we're going to imagine a sample of size 30. And so we can calculate the standard error. So the standard error formula is the square root of p times 1 minus p divided by the sample size. And then we're going to think about having an interval going from 0.05 below 0.6 up to 0.05 above 0.6. And then we're going to figure out the probability of getting a sample proportion inside that interval. So calculate the standardized Z value by subtracting the mean and dividing by the standard error. Same here, subtract the mean, divide by the standard error. And then calculate the probability to the left using norm.dist. So it comes to 0.2881 for Z equals minus 0.56 and 0.7119 for Z equals plus 0.56. And then the probability in between minus 0.56 and plus 0.56 is 0.7119 minus 0.2881. So it comes to 0.4238. What happens if we were to increase the sample size to 100? Well, the standard error becomes smaller because remember we divide by the sample size when we're calculating the standard error. So if the sample size goes up, the standard error goes down. We'll keep this interval fixed at 0.55 up to 0.65. So if the standard error has decreased, the normal curve is going to be tighter and higher at the mean. And so we're going to have more probability in between 0.55 and 0.65. And we can confirm that because the standardized Z values will be further away from 0. So they're going to contain a higher probability in between them. And finally, let's look at the effect on the probability of increasing the interval but keeping the sample size the same. Okay, so the standard error will be the same because we're not changing the sample size, but instead we're going slightly wider for our interval. If we're going slightly wider and the standard error stays the same, the normal curve will stay the same, but we're going further out from the mean, then we're going to have a higher probability in between 0.5 and 0.7 than we had between 0.55 and 0.65. So we go out further from the mean, so the standardized Z values will be further away from 0. And if they're further away from 0, the area to the left of minus 2.04 will be much smaller. And the area to the left of 2.04 will be bigger. And the difference between those two numbers tells us the probability in between. And that's going to be larger than the probability was when it was 0.55 up to 0.65.